This part right here is going to take a look at graphing a linear function and how we can use some sort of function or some sort of equation to come up with a graph. Now there's a couple different ways to do that, and we're going to take a look at a few of those later on. But for today, we're going to take a look at one that just looks at which points work on this line. So what we can do is we can find coordinate points that work for a function, okay, so that satisfy a function, and then these points can be joined to form a line. This is what we call a graphical representation of the function. So here we have a function. This is actually in graphic representation, okay, or in graphic form, which we'll talk about a little bit later as well. But what we do with this is we create a table of values which we can then graph out. Now, depending on what points we have, will depend on kind of what we want to use. But for the most part, what we want to do is plot about 2 to 4 points and then see what kind of line do those points form. Now the points that I would choose is I usually try to choose the values of x is 0, 1, 2, and 3. Okay. Sometimes there's different ones. Once we get to a little bit bigger graphs, we might start choosing some negatives as well. But for now, we're just going to take these values 0, 1, 2, and 3 and see what the y values for those are, which will then give us a coordinate point. So to get our y value, we're going to take our function y equals 2, and then we're going to plug in our x and add 3. In this case here, y is going to be 2 times 0, which is 0 plus 3, so it is 3. And then we do this for each subsequent point as well. We do y is equal to 2 times 1 plus 3. So it's 2 times 1 is 2 plus 3 is 5. Y equals 2 times 2 plus 3. 2 times 2 is 4, plus 3 is 7, and you might start to see kind of a pattern that's forming here. And y equals 2 times 3 plus 3, 6 plus 3 is 9. You'll notice that we're going up by 2 every single time. This is the way that, this is a pattern that is forming here. Okay, when we have a linear function, we're always going to have a pattern, some sort of way that it is either getting bigger or getting smaller. And that is something that we can look at later. We'll talk about that as rate of change or slope, which we're going to get into in our following lessons. But this is how we can then come up with what points we should graph. Now this function right here, okay, you notice it's going up by 2. There's a 2 there. That's not by chance. That's very, very specific there. And we'll take a look at why that is again later on. Let's make a little graph and let's graph this out here. Okay, that's my x, that's my y. I'm going to go up by 1s every time. So 2, 4, 6, 8, 10, and 2, 4, 6, 8, 10. Now you notice I said 1s, and yet I'm going up by 2s. I always skip one of them. So I skip 1, hit 2, skip 3, hit 4, skip 5, hit 6. The reason I do that, oh sorry, that was, you couldn't see that there. I always skip here. So I skip 1, I do 2, I skip 3, I do 4, and so on and so forth. The reason I do that is so that my graph is a little bit less cluttered. I don't need as many points here, as long as I know what kind of I'm going up by. Okay, if you want to do every third one as well, that works too. Or fourth or fifth, as long as you have a few numbers down here that show what you're going through and show where they're at. Now when we graph this out, let's plot in our points. We have this point here at 0, 3, and we're just going to label it 0, 3. We have 1, 5, which is right here, and so this is at 1, 5. And then we have 2, 7, which is right there, 2, 7, and 3, 9, which is right there, 3, 9. Okay. When we have points like this, please plot them out or write them out so that I know which points you are using, and just to make sure that they are in fact the same as your graph. Now, to graph this out here, we know that in this case here, there's no context to it. There's no restrictions that are a part of it. So we can just draw a straight line that goes through it. Every single point is going to be a part of this one, as it is, they're all valid. So we're going to draw a line through, use your entire graph, and then put arrows at the end of our line. Okay, so all points are going to work because we could pick any value of x and it could provide any value of y, and so every single point along this line works, and it's going to create a nice long line with infinite number of points, which is our graphic representation of this function. Okay. And then once we have that done, we're also going to put in our equation. So this is y equals 2x plus 3. We put that in there so that we know what that function represents. So we plot our points. We put in our equation so that we know what line this represents.